there in Chicago, and I actually had a group of students, and it was a very relaxed environment, even though, people almost competing against the computer rather than competing against other teams. So it was very collegial and very, but it's a good experience. So I'm not quite sure if they changed anything on the format, but it was definitely fun. So what I wanted to show you today, and hopefully it'll somewhat helpful. I don't have a lot of slides, as you might see it, and I posted everything, the files, on the URL that you see down there. This also includes the PDF of this presentation, and I hope that I just give you an idea, and basically what I want to do is walk you through the one of the problems, and how I approached it in the last couple of days. I spent a couple of hours trying to solve it, and maybe hopefully something rubs off and is interesting for you, and then you can hopefully have some questions, and I can help you maybe getting some pointers done. So now I need to find out how to go here. Oh. So quick outline. So basically, I looked at the last week's challenge, was the drunken dude, and let's just get in here. There's a lot of wordy. Quick question, feedback maybe. Did anybody try to look at these challenges at the HPC University website? No? Yes. Okay. Oh, okay. Very. So, okay. What's that? It's actually helpful because I can't see the chat right now, that window. So I can't see the chat. I just see like a little screen popping up for a second. So let's just. But that's good enough. So thank you. So I just wanted, it's so hard to get if I'm not used to doing a one-way. Usually I'm standing in the classroom and can look people right straight in the eye. So this challenge, I hope, excuse me, was actually kind of fun, and you see from the wording. So if you had a chance to read the whole thing, so it basically is it goes, it's the Greek mythology. Sisyphus, the guy who had to roll up rocks up the hill every day, and then he had to do this for, I guess, his entire life, or for the entirety, whatever. So this is a simulation that is, or the problem is to simulate that in a 3x3 grid, where we have a drunken dude who has to carry rocks from one end up, or from one side of the grid to the other side, and the dude does not remember where to go, so it's basically a completely random process. And that's kind of like, I don't know if you heard about the Brownian motion, or a random walker process. So at any time moving one step direction, so basically the chances to go from one in any directions are equal. And so we kind of just simulate that. And the question is here to find out how long would it take to complete the task. And so, of course, the rules are kind of fuzzy. There are a few things in there. But let's say we have these rules. They are given. Fortunately, if you're at the competition, you will be able, if there's something unclear, to ask people around it. I sent an email, but I hadn't gotten any feedback with some of my questions. So roughly, to try to understand the problem. So the dude moves on the grid. The problem, basic statement was like a 3x3, but then of course in the back of my mind I would okay, how would it be on a 5x5 or 7x7? It was talking about the pedestals that are on one side of the grid, and basically once a rock is moved there, then it won't be, it sticks, and it won't be, it would be removed. So of course we need to have a final end of that. Um, the way I understood it, because it's quite possible that the dude, the Sisyphus, could move a rock, carry a rock into another grid cell that already has a rock in there. Since there are no distinctions between the rocks, I just basically assumed that it would just take one. If he leaves the cell, he would just take one with it. And one of the things that was not expressed, but I assume it was that they're actually boundaries. So a lot of times, this is actually often you might have seen problems like that on a grid, for example, and often we use periodic boundary conditions so that we fold the edges. So what happens when you come to the left side? You basically appear automatically on the right side. If you fold these together, you get a tube, and if you then fold the top and the bottom edge together, then you would you create this kind of torus that you see on the left, and that would would simplify life a lot in simulations, because we wouldn't have to worry about getting on the edges or getting on the corners. Why is this important? Because the degree of freedom is different in these different cells. So that makes the code that I show you a little bit later a little bit more cumbersome, because if I'm on the top edge, on the top row, I can only go left, right, or down. So you see there, like the numbers indicate how many directions I can go. And the corners, of course, there are only 2 directions. On the edges, you had 3, and then anywhere else in the middle, you would have 4 directions to go. So these are kind of things I was considering about how to kind of create that. So my goal is, I want to create a simulation that simulates how this dude moves on the grid, and I need to make sure that I have a really proper random process running so that I can trust my simulation results. And then of course the logic that carrying the stones and everything has to be correct. So being faced with a problem like this, couple of design decisions. One of the things, okay, I need to use my computer, I need to program it. If you looked at some of the other problems, some of them have one of the things that comes to mind is like, okay, what is my internal data representation? How do I what is my data structure? What kind of variables do I need to, or values do I need to represent in which format? In this case, I think it's fairly straightforward. I need to have the position of the dude, of course, at any time, and I have to have the position of the rocks. That defines my environment. I decided to use a map, basically create a map and store the number of rocks per cell, rather than having the individual rocks and keeping their positions. And that was just a decision I made. There are often many ways to do it, so sometimes you might try to do one thing, and then of course it might not work out as well, might get too complicated, and then there's nothing wrong with backtracking and trying something else early on. So another decision, of course, is do I have any input data? For this particular problem, there are not really any input data, so that have to be processed. So I have some parameters that I want to modify, like for example the grid size, because even though the problem says this is for the grid of 3, but it would also be interesting to run it for larger grids and see what happens. And technically, of course, it should work the same way. And then probably because this is a typical problem where we have multiple simulation runs, so might have something in there like the number of simulation runs or other types of parameters.
Yeah, I'm going to stop for a second.
Mm-hmm.
If anybody has any questions at this point, we can do 1 or 2 questions and then go on. And what you want to do is type them, and if you type them,
Okay, I saw the.
You see it?
Can you read it? I saw a question.
Well, the first question is from Pedro, and it says, "What was the initial position of the dude and input?"
In this case, it's absolutely. In this case, the problem says the dude starts in the center, but it's a good point. Yeah, I should put an input in there. If I have it as an input, then I could test if there's, for example, a difference if the dude starts in the corner versus the dude starts in the center. So, good point. So in this particular example, because the problem said the dude always starts in the center of the grid, I just left it at that. But, again, it's nice to play around with it, and even if you basically write a program to look at something, you might want to add something to it just because you get, other types of questions that come up.